Hi, I'm Beth Morling from the University of Delaware, and I'm here to explain a key concept in Chapter 3 of this textbook, specifically how to interrogate a causal claim. You're ready to watch this video if you've read Chapter 3 of the book, or if you're studying causation and correlation in one of your classes. In this video, I'll review what a causal claim is and review the 3 criteria which we use to interrogate causal claims. And then most importantly, we're going to be working through 2 examples, one in which causality is probably justified and one in which it probably is not. So in Chapter 3, you learn about causal claims, and causal claims have 2 variables which are joined by a causal verb. So here's an example, how your identity impacts the food you like. This is a headline that a journalist put on a story about an empirical journal article by a psychologist. In this claim, the 2 variables are identity level and which foods you like. And they're joined, the 2 variables are joined by the causal verb impacts. That makes it a causal claim. Here's a second causal claim, again by a journalist covering an empirical journal article, which reads, "An all walk might do wonders for your well-being." In this case, the 2 variables are doing an all walk or not, and the level of well-being, and the verb phrase is do wonders for, which is pretty similar to improves, also a causal claim. Here's a final example of a causal claim. Mother's friendships may be good for baby's brains. So the first variable is how many friendships the mom has, or maybe the quality of the friendships. And the other variable is some quality of baby's brain development. And the may be good for is an example of another causal claim. So being good for or improving baby's brains. Notice that might and may, these are adverbs that I request you don't really pay attention to when deciding if a claim is causal or not. I think it's better to focus on the verbs. In table 3.4, you can see some examples of causal claim verbs. You can see that these are all pretty strong, like makes, worsens, distracts, prevents. In contrast, association claims also have 2 variables in them, but they're linked with more neutral verbs like linked to or at risk for or associated with. Causal claims are pretty powerful claims, and so we hold them to a higher research standard than other kinds of claims. And specifically, when we interrogate a causal claim, the study behind the claim needs to meet 3 criteria: covariance, temporal precedence, and internal validity. Covariance is about the study's results. It requires that the study show that if we have 2 variables, A and B, that the results show that A and B go together, that they covary. Temporal precedence is about the study's method. And so temporal precedence requires that the study made sure that the A variable, the causal variable, came before in time the result variable or B variable. And internal validity is also about the study's method. And it requires that the study ensures that there's no plausible alternative explanations for the change in B. So sometimes we call internal validity a third variable or alternative explanation. Here are definitions of these 3 criteria. And here's another version pictorially of what I'm talking about. So covariance is when A and B just simply go together. You can see that the arrows go in both directions, indicating they're just going together, they're covarying. Temporal precedence is asking whether A came first in the study, followed by B, or did B come first, followed by A, or maybe we can't tell. And then the third variable or internal validity criterion is about this outside variable that might be responsible for the link. So those are the definitions of the 3 criteria. And now it's more important, and you'll learn them better just by watching us explain how they work in 2 examples. So here's the first example. This is the one about your identity impacts the food you like. This is the journalist's coverage of this empirical journal article, which appeared in the Journal of Experimental Social Psychology. You can see that even the researchers put a causal claim on their article because they said social identity shapes evaluation of food pleasantness. So here's how the article in the study originally appeared in the journal, and here's what the journalist said about it. This is a causal claim, so let's read about the study behind it. This is a summary of the study that the journalist wrote. I want you to focus here on this central paragraph. You can see that in the study, a group of Canadians were randomly assigned either to think of two things they do really well and to draw themselves, that's called the personal prime, or to think of two things that Canadians do really well and to draw the Canadian flag. That's called the Canadian prime. Then all the participants tasted both honey and maple syrup and rated how much they liked it. And the results showed that people who were primed with the Canadian identity rated the maple syrup higher. Okay, so let's practice a couple of skills from chapter 3. I want you to read that paragraph and think about what are the two variables in the study, and think about for each variable, was it manipulated or measured? And was the study an experiment or a correlational study? I'll pause for a second while you ponder those questions, and please hit pause so you can think about it a little bit longer. Okay, let's go over the answers. The two variables in this study were first, what participants wrote about and drew. So they either wrote about Canadians and drew about Canadians, or they wrote about the self and drew a picture of the self. The second variable was their rating of maple syrup versus honey. And I think in this study, they're mainly looking at, did they rate the maple syrup higher than the honey? So those are the two variables. This first variable was manipulated. And the reason you know that is because it says people were randomly assigned to think about one or the other. Random assignment is a key phrase that lets you know they manipulated the variable. Participants didn't choose which condition they were going to be in. The participants were assigned by the experimenter. The second variable is the measured variable, which is how well they rated maple syrup versus honey. This study was an experiment, and the reason why is because it has one manipulated variable. And anytime a study has at least one manipulated variable, you should call it an experiment. And if all the variables are measured, it's a correlational study. Okay, here's a quote from the journalist's article, and here's my sketch of how the results turned out. So here we have the Canadian flag prime, this is the self prime, and on the y-axis is the measured variable, or the dependent variable, which is preference for maple syrup. And so this isn't the exact result from the study, this is my sketch based on this phrase. Now, let's interrogate this causal claim that drawing the Canadian flag causes people to prefer maple syrup over honey. We're going to apply the three causal criteria: covariance, temporal precedence, and internal validity. First, we'll go through covariance. Do the results show that these two variables go together? Well, yeah. The results show that people in the Canadian flag group preferred maple syrup more than people in the self group. Being in this group covaried with a higher rating of maple syrup. So covariance checks out. And remember, covariance is about the results. So you're going to look at the graph or the statistics of the study. What about temporal precedence? Yes, this checks out too. Because this was an experiment, we can be sure the Canadian flag group came first, or the prime came first, before they rated maple syrup. This might seem like kind of a no duh, but of course this is why we do experiments, because then we can be absolutely sure that what we think is the causal variable, we make people do that first, and then we measure their preference for maple syrup. So temporal precedence is met in any experiment. What about internal validity? Remember that internal validity is about the study's method. And in this case, the experimental method does achieve internal validity, in my opinion. One aspect of internal validity is the random assignment that they used in the study. When they use random assignment to put people in the two conditions, it makes the two conditions equal on a lot of individual difference variables that you might think about as an internal validity problem. So just a reminder that in random assignment, the researchers flip a coin or use a computer randomizer to randomly assign people. Say they say if it comes up heads, people are placed in the Canadian flag prime group, or if it comes up tails, people are placed in the self prime group. Now, sometimes when people see the results here and they read this causal claim, they might say something like, well, maybe the Canadian flag group, maybe people in that group just like maple syrup better, right? Some people like maple syrup better than others, and that's absolutely true. But random assignment takes care of that problem. And the reason why is like this. Let's say there's about 60 people in this experiment. And let's say about 20 of those 60 people just love maple syrup. When you use random assignment to put those 20 maple syrup lovers into the two conditions, it's probably going to put about 10 people in this and about 10 of them in this condition. So we take this potential internal validity problem of already liking maple syrup and we get rid of it because we evenly distribute the maple syrup lovers into the two conditions using random assignment. Other people might say, well, maybe people who grew up in northern parts of Canada like maple syrup better than people who grew up in southern parts of Canada. And maybe that's why these guys are higher. That may be true, but again, where people grew up is going to be evenly distributed across the two conditions when you use random assignment. Same thing with gender. You might say, well, maybe women like maple syrup better than men. Possible, unlikely, but possible. But again, random assignment is going to put the women in both groups equally, same with any other gender. So random assignment is one big feature of a study that can ensure its internal validity. Another thing that we look at for internal validity is the potential for experimental mistakes. So we also would want to be sure that they treated the two groups exactly equally on everything except for the active ingredient of the Canadian prime. So in this study, they had both groups draw something, they had both groups remember something. So you can't say it's just having made a drawing is the reason why this group likes maple syrup more. Instead, they made sure that both groups drew something. They just drew something different in the two conditions. So that's about experimental confounds, which you learn about more in chapters 10 and 11. Okay, so I believe that this study meets the internal validity criterion. Because all three causal criteria are supported by this study, I believe it can support the causal claim that drawing a Canadian flag causes people to prefer maple syrup over honey. It activates their Canadian identity and impacts the food they like. Okay, let's do a second example. Here's a second example about a study on dog ownership and longevity. And the journalist who wrote about the study put this headline on it: "Dog people live longer." Now, on its face, this is actually not a causal claim. This is an association claim. The two variables are being a dog person or not, and how long you live. And they're joined just simply together as an association. This is what dog people do. They live longer. And it's not asserting that owning the dog causes you to live longer. Here is a description of the study. It was published in this journal, and it suggested that dog ownership is linked to a reduction, 21% reduction in the risk of death over a long period, 12 years that they studied the participants. Now, even though this headline is not a causal claim, there is a causal claim in an interview that the journalist conducted. So here's a researcher that they interviewed, and the researcher said, when you look at the big picture, it's pretty clear that the signal is real. That means the result is replicable and likely causal. So this researcher is asserting there's a causal link. So let's ask about this study. Is it an experiment or correlational design? Well, let's go through the variables. So the variables in this study are dog ownership, yes or no, and longevity of the person, how long they lived over a 12-year lifespan or 12-year span of the study. This first variable is measured, and we know that because people are unlikely to be willing to be randomly assigned to either have a dog or not have a dog. People who want a dog are going to want to have a dog, and people who don't want a dog don't want to be assigned to have a dog. So we're pretty certain that this is a measured variable. Longevity also measured because you can't randomly assign people to live a longer life or not. Because both variables in the study were measured, that makes this a correlational study. Okay, so here's a little sketch of the results that they described. Again, these are not the actual results from the study. This is just my sketch of what I picture when I read the journalist's coverage of it. That owning a dog is on this axis and how long people live is on the y-axis. Let's interrogate this potential causal claim that the researcher that was interviewed wanted to make, that owning a dog makes you live longer. Again, we're going to apply the three criteria for causation to this study to see if this causal claim can be supported. What about covariance? Yes, this study does meet covariance. Remember that this is about the results, and this study does show a relationship such that owning a dog goes with having a longer lifespan. What about temporal precedence? Well, sometimes correlational studies do not establish temporal precedence, but this one did. And we know that because the method of this study measured dog ownership first and then followed people in the study for 12 years. So we can be really sure that the dog ownership came first before the lifespan was established and measured. So temporal precedence checks out. What about internal validity? Well, here's where we meet a snag because a correlational study like this cannot meet internal validity just by itself. Here's why. The method of this study was correlational, not experimental. And when you have a correlational study, it's possible that there's some unmeasured third variable, this C variable out here, that goes with both dog ownership and living a longer life. So what we're saying is if A is dog ownership and B is having a longer lifespan, there may be some outside variable, which we'll call C, that could be going with both of those. We might say it's lurking in the background. Here's an example. It's possible that in this study, people who started out healthier at the beginning of the study were more likely to own a dog. And that makes sense because if you have a lot of health problems, it might be too much of a burden to have a dog. They need to go for walks, they need to be disciplined or trained. So you may not be up for that if you're not a very healthy person. So it's possible that people who started out healthier were more likely to have a dog, and people who started out healthier at the beginning of the study are probably more likely to have a longer lifespan by the end of the study. So that's a possible third variable. Another potential third variable that might work is wealth. It's possible that people who are wealthier may be more likely to have a dog and afford a dog. And it's certainly true in our culture that people who are wealthier tend to live longer because of differential access to the healthcare system. So wealth might be a potential third variable in this study. Now, when you are deciding if something should be a third variable or not, you need to really think about it logically. And sometimes the third variables that you think of may not work. Here's an example. You might propose that living alone is the third variable that's responsible for this relationship, but I don't think that would work for a couple of reasons. First, it may be the case that living alone actually goes with a higher likelihood of owning a dog, so that's possible. But in fact, because we know that social support and social relationships are important for people's physical health, it's possible that people who live alone actually don't have a longer lifespan. So this living alone variable may not go in the way it needs to go with these two variables in order to be a plausible third variable. So when you're thinking of those C variables, you need to think through, does it go in the predicted way with both of the A and B variables in the relationship? So anyway, let's review. In this particular study, we can't support this causal claim because even though the study showed covariance and it showed temporal precedence, it didn't establish their internal validity. Therefore, we can't support the causal claim. Now, in Chapter 9, you will learn that in some cases, you can use statistical techniques like multiple regression or path analysis to rule out some of the C variable alternative explanations. And there are always other studies that we can do, and we can look at the body of literature. And sometimes when we step back and look at the whole body of literature on a topic like this, we can infer a causal claim. But on its own, this particular study, which is correlational, cannot support the causal claim just by itself. So this researcher probably shouldn't have said this about the study. Now here's a couple of big picture points. When we're looking at causal claims, we fit it into this big matrix of 3 claims for validities like so. Causal claims are up here. Causal claims are one of the 3 claims and the strongest of the 3 claims in my view. And internal validity, which is the third rule for causation, is also the third big validity. So when we're interrogating the internal validity of a causal claim, we're asking questions like we would do here. Was the study an experiment? Does it control for alternative explanations? Does it avoid internal validity threats? So that's one big picture point about what we've just been doing, where it fits in the grand scheme of things. And again, here are the 4 big validities. Here I've put internal validity last on the list. And it just reminds you that internal validity is about alternative explanations for changes in A and B. As we close out here, I have a couple of retrieval practice questions for you. You learn more by trying to pull things out of your brain than by stuffing things into your brain. So let's try retrieving or pulling things out of your brain with these questions. First, what are the 3 criteria for causation? Pause the video until you think of them. Okay. The 3 criteria are going to be part of the next question, so you can check your retrieval next. Here's a multiple choice question for you. What did you say? A is the correct answer. Covariance, the first rule, is about the results, and temporal precedence and internal validity are established by the study's method. And here's another retrieval practice question for you. What kind of a study does it take to support a causal claim? A well-conducted experiment. So here's the take-home message. If experiments are well conducted, they can usually support causal claims because they meet all 3 causal criteria. Correlational studies on their own usually cannot support causation because they usually meet only the first criterion. In your travels, you've probably heard that correlation is not causation, and you may have even heard this: inferring causation from correlation is too scary for words, or correlation does not imply causation. In fact, the problem is correlation does imply causation. It does, but we have to meet the other 2 causal criteria, temporal precedence and internal validity, before we can support causation. Most people are able to say that correlation is not causation, but they can't actually tell you why it cannot. And now you're ready for an answer of why correlation is not causation. It's because a correlational result on its own is just covariance. The study behind the result needs to support temporal precedence and internal validity. So if you want to know if correlation is causation, you have to look at the study as well, the study's method as well as its results. That's all I have. Thanks for listening.